Om Sahana Bhavatu Sahana Bhunaktu Sahaviryam Karvavahai Tejasvinavadhitamastu Ma Vidvishavahai. Om Shanti Shanti Shanti. Welcome everybody. So for we're doing it for the first time, typically the format has been quite open. There is no format. I keep it open for people to share how the experience has been, or if there is something they want to share or ask as the journey is continuing. So yeah, we can keep it that way for some time, open or otherwise. And the other option which I have been contemplating is that would it be helpful if sort of I kept some 20-30 minute very basic content, so things like introduction to the nervous system or some concept which not necessarily, it will link it to our yoga practice of course in some ways, but it may come from a very different direction or sometimes directly also. So, leave it to you. So I think one time we tried to cover, for example, it could be things like the life of somebody like Buddha, sometimes the life of Christ, nervous system, or some concept from physics which might be relevant. Yeah, that's another way also to tee off the conversation. So both options are there. Any preferences? Yes.
Actually, I don't have a problem. Even if you start with that, somehow something will connect to the work we are doing.
Of course, no, it will be connected.
Yeah. So we could start with that also, Sandeep.
Okay. Huh? So I'll maybe leave it. Others, how do others speak? Yeah.
A good idea.
Sounds exciting. Shushri says, who said good idea, Pooja? Yes, okay. Some of it for some people might be also repeat because I know this is BIY. So some content I might borrow from the science and sometimes it will be fresh, but it will always be a refresher. I think some of this content always is worth reviewing. So for me also, every time I share, it's interesting.
It is, and every time, discussion actually deepens the experience. So there's always learning.
Yes. So Megha, how do you feel? Sushri, Pooja?
I think the format sounds good. Both of them, like you can share, and then I think in that sharing we will have something to share.
You could correlate it with that, whatever is there. But I'll start with, if I think since that's there, anything specific anybody has wants to bring, I'll keep a minute or so, and if not, then we'll get into that. I thought of something, so it'll be largely impromptu, but I'll share about the nervous system.
I was thinking of brain health. So just your point of view on, in a sense, what affects it negatively or what should be done.
So good. That's nervous system. So we'll start with, if you understand the nervous system a little bit, then we'll be able to address that. Okay. You were saying brain health, very specifically. That's interesting. Okay. Anybody else? Any other things or any thoughts, questions? No? So good, we'll start. Let's see. So this is partly cooked, partly we'll see. So it's how many of you saw the earthing video, by the way? Did anybody see that earthing video or that I shared?
I did.
Yeah,
Oh, you,
yeah, we have
oh,
seen it.
so
I
you have
saw
seen-
it long time back.
No, the one that I shared in IY, the Indian
Oh,
Yoga Day.
okay.
No?
Was
Oh,
it something
no,
different?
no.
Okay, no, then I have not seen that.
Oh, it is different. Yeah, this
Oh.
is. I
Yeah.
recorded it specifically on earthing on no. Okay, Sushi,
Oh, okay.
Jaya not. Mega, did you? You said you've seen that.
No,
I
no.
did. And then I ordered.
Okay, but now you will share a part of it. In that I introduced the nervous system, so I'll introduce that here again. So most people haven't seen it. It seems like so good. So
No,
then
no.
we'll go ahead with that. Okay. So yeah, so I'm using those slides only, so you'll see the agenda. But let's go with that. Okay, so let's start with the systems. Okay, so basically biology, it's very important to understand how is in general, at least in biology framework, how it is organized, right? So biology starts, the unit of biology is a cell, right? So unit of physics is at least electrons, protons, neutrons, right? But it might even be quarks now, from which electrons and neutrons are made. But then basically those neutrons, electrons form molecules, right? And a kind of molecule is biomolecules. So molecules is what chemistry is about, atoms, molecules. Physics is about electrons, protons, neutrons, right? And then those specific kinds of molecules are biomolecules, which come together to create cell. So unit of biology, in some ways, a unit of life, at least we can say very safely, is a cell. Now these cells organize themselves into, in biological systems like ours, what are known as tissues, right? So for example, there is a muscle cell, and a muscle cell will come together as a muscle tissue. So like even if you look at these arms, right, this has multiple cells in it. A muscle like our bicep will have multiple muscle cells. Okay, so that is known as a tissue. And now then tissues further organize themselves as organs. Okay, so if I take an organ like, let's say, a kidney, right, it is made from cells called as nephron cells, which are the kidney cells, and many cells come together as a tissue, and then that tissues come together as organs. So even our kidney organ will have some muscular tissue, and it will have some nephronic tissue, which is for the purpose that the kidney has, and that creates an organ, right? So multiple cells create a tissue, multiple tissues create an organ, and multiple organs create a system. So like our urinary system is made from the kidneys, it has a bladder, it has the urethra, and then it has the external organ from which the urine is passed. So just the excretory system, for example. Similarly, our cardiovascular system has the heart, it has the arteries, it has the veins. So it is multiple things, and then it has a network of those, right? So multiple organs, tissues will collectively form a system. So that is how biology is sort of organized. And now when we talk to a medical person, these are the systems sort of identified in the body. These, and the number varies because sometimes some people club some systems as one together and some don't. So here we have 10 systems, right, which different purposes. So the first, let's say, is the immune system. This is a completely different system. And why are they different systems? Because their unit cell is different. So immune system, the cells of the immune system are different. There are what are known as T cells or white blood cells, which are the fundamentally, it is supposed to fight any micro sort of foreign body in our system. Right, foreign body defined as where the DNA doesn't match. So any other life form where the DNA is not the same, it is supposed to fight it, protect us from them. That's the immune system. Then we have the digestive system, right? This runs from our mouth to anus. So it's actually very interesting. It's one single pipe. It's so beautifully organized. Someday maybe we'll go deeper in it, but it's such a beautifully organized system that it's one pipe, right? Something enters from here and during its journey, we extract out. So we take an apple, and from that we extract, we break it down, we are taking out what we need, we are then passing through what is not needed, and that's actually excreted. And that cell which is in apple becomes our own cell. From that we make our cells, right? So the apple, the chemical in the apple becomes somehow transformed into the chemical which goes in our cell. And that happens through this one. And one of the simplest ways to see that is in actually an earthworm. So if you imagine an earthworm is just a tubular thing, right? And it has a very similar, very complex digestive system. It has a mouth from which the whatever it eats, and then it excretes. And that's why it's good for the soil, because what it excretes becomes a fertilizer for the soil. So it's a wonderful system, and earthworm is very easy to see, visualize it, right? And that's exactly how it is for us, for any other mammal, even higher evolved, all mammals are like that. It's one single pipe. It goes through, it twists and turns, etc. So apparently, if we open up our entire digestive tract, this is trivia, very interesting. It's 9 meters long. 9 meters, that's 27 feet or 30 feet long. Our height is 5.5, 6 feet, maybe 6.5, but this is 30 feet long. So 5 times our length is all coiled up there, and the food has to pass through all this. So it's quite a task. And yeah, maybe someday, as I said, we'll go deeper in it. Today our topic is nervous system, but I'm giving a quick highlights so you can start seeing how wonderful, I think, amazing the body is. Then we have, of course, the cardiovascular system, which is largely the hearts and the veins and arteries. Basic job is it's like the pump house. It fuels everything. Blood is the carrier. So blood is known as a connective tissue, by the way. So blood is a tissue. Tissues are not hard only. That's why I want to highlight that. We imagine tissue, matlab, it should be something hard. No, blood is tissue. It is a connective tissue because it connects everything. So it flows. So tissue can flow. In fact, all tissues flow. And that's another beautiful property. We'll maybe again someday cover it, but take it for a fact, all tissues flow. Even what we see here in our skin, all this, which seems like solid matter, actually can flow. That's the beauty of science. But cardiovascular system, basic job, circulate every nutrient, every material, so that it reaches every nook and corner of the body. Again, a wonderful system. Arteries are very thick, but by the time they reach every cell, they become very small, called as capillaries. So very thick artery, which we can see here. This is the artery that we see in our wrist, where pulse is usually measured. That's an artery. It's very thick, right? It feels very solid, but it keeps getting branch into thinner things, where finally it becomes a capillary, very thin, nanometers, 10 to the power minus 9, very thin. And then that's where the interaction happens. And in the other side, capillaries then form and become veins, where the sort of blood, the second part of the cycle starts. So veins are what we see where, for example, blood is drawn. You would have seen. So that's a vein, what we find here. And those are much thinner. So that's why they are pierceable more with a syringe. An artery would be very difficult. The pressure in the veins is also much lesser. So it doesn't harm when we do. If we burst an artery, the blood will ooze out, because as soon as the heart pumps, it goes with full pressure in the artery. So that's the cardiovascular system, basic job, moving. Integumentary system, very complex name for largely the largest organ of our body. Do you know what's the largest organ of our body? So science and biology, जिन्होंने करा है, उनको
Skin, no?
Huh? Skin, yes,
Skin.
the skin. Skin is one organ. It's actually quite amazing. It's a single organ. The entire skin is connected. It's amazing. So actually they did that in one of the amazing classes. Usually anatomy, when we dissect say a cadaver or something, we dissect it like this, right? We'll cut it like this to see where is the bone, what is there, artery, etc. But some very interesting people decided to cut it like this, which is slice it. And when they sliced it, they peeled, they actually were, and their goal was to sort of come out with one jumpsuit. So from here to here, they had one jumpsuit to just show how connected again the skin is, that it's one skin. it's one organ. So that's the integumentary system. It's a largely the skin. Biggest function, it's the first line of defense. It's our boundary. Fundamentally, it's our boundary, right? This is what really physically separates what we define as this unit of life and what we define as outside, right? Not this life. So it's a boundary for many things, and boundaries are semi-permeable and flexible. Two very important properties of a boundary. Semi-permeable means it allows for exchange. Things can come in and go out, but selective. It's selectively semi-permeable. Not everything can come in and everything go out. It's a hard barrier for some things, but like a soft barrier for others, right? So sweat can go out. Very important. Sweat is excretion again. Not having sweat is like not urinating or defecating. Very important. It's very important, but now socially sometimes we feel very awkward, and our brain, we have tuned it to not sweat. Many people do that. They just dislike sweating. So they tune their brains to not sweat, and they don't sweat. They think it's great, I don't sweat, but it's actually you have blocked the channel for excretion, right? So it is body's natural mechanism to let go of certain waste, which is best done through the skin. So that's there. And also prevent, it's not transparent. So it will first line of defense. Macro ingredients can't pass through. Oftentimes most bacteria can't. So it's again preventing, right? Otherwise, a bacteria are constantly hitting us. So that's why we take a bath to remove, right? So that you're not letting it be there for long enough to penetrate. Like वो चूहा है ना, चूहा तो कहीं भी खुरेद के चला जाता है, उसको टाइम मिला तो. So you don't give it time, you just wash it off. So that's why that bathing is so important, that otherwise you're giving it longer time to penetrate more, they will multiply, all that might happen. So it's the first line of defense. Integumentary system, very important against skin. And even for earthing, it's very important. Very beautiful properties it has. Even for example, earthing, it won't be equally happening from every point in our body. So our palms, our feet, the skin is very different. It allows for that. And particularly if you apply a little pressure, it will make the conductivity easier. So the earthing will happen more easily. So when you sit with your feet and apply a little pressure, then the conductivity will be better. Than you don't have to force it, just your weight is applying enough pressure. But if you keep your feet like this, it will be different. Or you connect it at a different point, it will be different. So lots of amazing properties. The electromagnetic radiation that's there, it won't generally just penetrate our skin. If it does, we wouldn't survive. So that's why we have to pass X-ray, right? X-ray is a very high energy, high frequency thing. A normal light doesn't go. If normal light, we are always in electromagnetic radiation, right? If that was to penetrate our skin, we are gone. The brain fry ho chuka hota. But X-rays, it goes. But then we have to reduce the intensity a lot so that it doesn't harm. That's why we say repeated exposure shouldn't be there. All of that is there to prevent that. So amazing, again, an amazing system. I saw a hand up there. So Sanjeev, any questions? I'll take a pause also before I continue to see any thoughts, comments on whatever the 4 systems we have covered.
Yeah, I was thinking comparing our skin with fruits we eat, then I think somehow my question kind of got clarified and answered when you were explaining, like how mango skin or mango peel or orange peel or apple peel, banana peel, like how they are different and kind of relating to our skin. So
yeah, it is. Yeah, good. It's a good comparison, actually. Very good. Because the purpose of the peel there is what again? To protect the fruit.
Yeah.
First, right? So it's to protect the fruit so that till the time the seed is matured, the fruit doesn't get destroyed. There is inside finally a seed there, which is the source of new life. That's how nature has beautifully evolved it. And same way it's for us. The skin protects. The fundamental role is protection. Like a banana, if you peel and keep, it becomes black, right? It starts getting, still the peel is there, it protects. And you can see how the skin also changes from green to yellow. As the fruit is getting ripened, the skin changes. Same with all fruits, because that's the purpose. Yeah, that's a good comparison. Yes.
Also, the skin has very many properties, very many nutrients. So while it is also protecting, it also has those qualities, no? The
Like-
nutritional properties. Like if you look at the skin of, say, apple,
Ah,
so there's a lot. Usually we peel off the skin, but the skin has a lot of properties which we may miss out. So likewise, I think the human skin is also, I don't know about the nutrients, but the kind of boundaries that it sets for the whole, what do I say, protecting the muscles and the skeletal system. I think that's amazing.
everything from macro to micro,
Micro.
right? In fact, to pierce it, that knife has to be really sharp. A blunt object doesn't necessarily pierce it. It's quite strong. You have to really have a very sharp thing to pierce it. So it's very good. And many people, like you will see, it can get trained. It has such amazing properties. Like barefoot runners. Initially, if you start running barefoot, it is harder. But once it's used, you run barefoot. People run on the road, on tar roads barefoot. Once you train it enough. So the skin can adapt. It becomes really rigid to the surface it's exposed, for example. Very adaptive.
One more question. So when somebody's weight increases or loses weight,
Yes.
is it a layer of skins which kind of also get formed and then they lose, or it's
Though my understanding, not skins. Skins will stretch and come back. There is that stretching that
okay,
happens,
okay.
but not layers.
But
The
it's
structure.
others.
It's mostly inside fat, and the inner layers are where the weight is mostly, not in this. Some thickness might happen, but I don't think a layer gets added. The layers might get thicker. That might happen. There is that adipose tissue and some subcutaneous levels. Some things happen there.
Okay.
From what I understand.
Because what I personal experience that, I over period I worked on and lost some weight, but then my body became sensitive to temperature. Like earlier, I won't feel cold or hot as much as I started feeling afterwards. So
That could be a function of two things. Two things, and we'll see. One is just your nervous system will become more aware. Whatever you did to lose fat made you more aware.
nice.
So what you earlier you didn't perceive, now you're perceiving. It was still there. One.
Yeah,
Right? And the second is there will be also that insulators, like which will dampen your nervous system, like adipose tissue, etc. The fat layers does do that. Again, your sensitivity will go up.
Thank you.
Yeah. Any other thoughts on other systems? Okay. I found the skin as the organ very fascinating, and yes. On barefoot running, if you're not barefoot, you're overdressed. Yeah. And that's why even in animals like a horse and all, you see those hooves, right? It's that skin which has gotten, their skin has become very different because of that exposure, etc. Okay.
I have a question.
Yes.
Whatever we apply on the skin, till what level does it penetrate? Because sometimes we hear, okay, local application of any gel, cream, it will help you to a certain bit, but it will not help you, let's say for, I don't know, knee ligament repair, etc. So is there any thoughts on it, any understanding on
So
it?
what you're saying, there are two separate questions. One, how much it penetrates. Second is what you applied, what is its role? So for what that means is like ligament repair is a different role altogether. Right? What you need to do to repair, I don't think that thing exists. whether it penetrates or not, the chemical that will penetrate doesn't exist. So ligament repairs they end up doing through surgery and all is what the current understanding of science is. But whether it, like if you apply a painkiller, like whatever painkillers are there, that chemical can penetrate. So it will subside the pain. But it won't repair there is no chemical which repairs the ligament.
And should we always prefer a local application rather than taking a medicine? Or is it like there's no general rule?
I don't think it will finally get into your bloodstream. It does, because finally when it penetrates your capillaries, veins are there, it's very likely to go there. Very likely. Again, the difference might be for some things, for example, painkillers, if you have usual acidity, painkillers tend to cause acidity. So when you consume them orally, that chemical is sitting directly in your stomach and your stomach ends up secreting more acid. But if you apply locally, that might not happen because the stomach is not involved. So that kind of, benefit might be there. Same is true for insulin for some. Now there are even other reasons why insulin patches are coming up. Yes, like Sushri is saying, pain patches are there. The other thing that you can do with this also for pain patches, as Sushri said, you can lower the dose of the chemical. So when you consume, you add over than you need, because you know some of it will get destroyed, not all will reach. But in that process, sometimes more reaches than you need. So particularly again, painkillers, which can be addictive, you can lower the dose substantially. So less of the chemical is given. You lower the dose. That's also another reason to give it intradermally. So like insulin is given subcutaneously. It's actually piercing the layers of the skin and given inside, because that's where it's absorbed the best, not oral. So now they're thinking of inhaled insulin because they're finding insulin can be absorbed here also. So those delivery mechanism depends a lot on the chemical also that you're using. So every chemical can't be given through the skin. Good. So any other, like anything, so good skin we have gone, let's discuss immune, digestive, cardiovascular. Those are Pandora's box, I guess. Digestive and cardiovascular. Anyways. But if there are any quick questions, let me know. Otherwise, we'll move ahead. So, so respiratory system, of course, lungs. Lungs seem like the primary organs because they are biggest, but it's again very evolved. It starts from our nose. Then there is the larynx, pharynx, trachea, and then it goes into the lungs. There's obviously sometimes some engagement of the mouth also in respiration. And then respiration has two components. Usually they will say external and internal. External is the exchange, which happens outside at our nostril level. Internal is actually in the cellular tissue, which branches as the lungs branch very beautifully at the cellular level where carbon dioxide and oxygen are exchanged. That's internal respiration, right? So that happens right at in the blood as the blood is flowing. So you can imagine such a beautiful system again, right? Blood is being pumped and it passes through a filter where carbon dioxide is held back and oxygen is passed, and the blood goes in rich in carbon dioxide and comes out rich in oxygen. Such a beautiful filter is there, right, at that level. We haven't designed it yet in our engineering, but nature designed it or evolution has designed it. So amazing, so precise, so wonderful, right? And that's what the respiratory system is about. Then we have the endocrine system, again an amazing system. This is a system of lot of glands more than organs. All the hormones that are secreted, like our pituitary, our thyroid, sexual organs, thalamus, pancreas, insulin is an hormone, liver. So many glands across. But the most important role of these hormones is they are signaling again. So they are parallel to the nervous system in some ways. These are chemical messengers. Very important part. They are again a messaging system in the internal, but they are more macro messaging, slow messaging, because for this message to happen, the chemical is secreted in our thyroid, which is in our neck, right? It's put in the bloodstream. Now for it to reach my feet or another place where, like stomach, that blood has to flow. So that takes, right? We know it takes a few seconds at least, right? If not more, because it's 72 beats. So that blood to flow through in a beat, it'll take some time. And that's why it's a slow but a longer messaging. So sustainable changes happen through the endocrine system also. And that it has a strong feedback loop with the nervous system. Reproductive system, the primary function is to pass on the gene. There's a whole book called The Selfish Gene, very popular book, which is around that. It sort of puts the emphasis our entire being is about passing on that gene, but that's the role of the reproductive system. Again, fantastically engineered, very minute, very beautifully engineered system, how this gene has to be passed on. And it's not equal. So one thing, one interesting or whatever fact, since we have majority of women in the audience, I thought they will like to know this, that there is part of the genetic framework that every person, including me, or male or female, both will have, which only comes from the mother. So we think 50% of the genes come from the father, 50 from the mother, and that creates a cell. The first cell, that is not true. There is part of the genetic system which is particularly in our mitochondria, which is outside the nucleus, which actually comes only from the mother. Right? So even in that, the other interesting thing that I learned about this, two other important facts I learned about this reproductive system very recently. One is the fact that during a pregnancy, we think again the flow is one way, right? That all material is shared from the mother to the child. But the reality is that certain cells of the child are also back channeled to the mother. So there is the child's DNA or parts of it that is there in the mother. And that stays, and it takes time, sometimes even tens of years or maybe longer before it actually completely goes out of the system. So this whole thing around mothers have a special connection, etc., is there. There is now biological basis for this to happen. So these two things I found very fascinating and that it seems it will be there. It's just getting discovered now, right? It's happening at such a microscopic level that we would think it's not there at a macroscopic. But one, the DNA pass on is very unique, distinct from the mother, and same is the back channel. The third amazing thing I learned, I feel it's amazing, is again around boundaries. That in the placenta, which connects the mother to the unborn child also, right? During pregnancy, there is a barrier. There is a boundary. So even the mother, right from that point, has to have a boundary with the child, which oftentimes get lost in this motherly love in real life, and mothers tend to sacrifice too much, and that's the image which is created. So sort of in contradiction to that image, or I want to highlight this notion of boundaries, particularly for mothers, to say that even nature has created that boundary, because it says whatever now, once the metabolism of the fetus, of the unborn child is also started, there will be waste produced. So that toxin shouldn't come into the mother. So to protect the mother, that boundary is created. Again, that boundary is selectively semi-permeable and flexible. All boundaries in nature are selectively semi-permeable and flexible. Right? So it's not a rigid boundary, but it will allow for exchange. So as I said, some things do come in from the mother, from the child, fetus back channeled also. So it's not opaque completely, but it prevents a lot. So that boundary is very important. And that nature has created, and that I feel has to be maintained even later on in life in a psychological sense, right? That boundary is there. A lot that we discuss a little bit more in science and biology. So people have done that know a little bit more, but just the concept of that boundary is very important. So that's a little bit about the sort of trivia about the reproductive system before we go a little more detail in this. Yeah. So any thoughts, questions before we move on to the next two and then get into the nervous system on these three: respiratory, endocrine, reproductive? Yes.
So Sandeep, in that sense, like the whole body, the whole everything is kind of being managed by these organs in a way, right? Based on our that how we are at that moment, physically, mentally, and all. Like endocrine system, respiratory, skin, all are acting to kind of bring that,
Yes. We'll
balance.
see that. the role the nervous system plays in that. That's why I've kept the
Ah.
nervous system for last, and we'll
Okay,
go
okay,
deeper.
okay.
Like exactly what you're saying. Yeah.
And
Yes,
then
there
food
point.
is some, yeah.
Hmm.
And then food is something which we control, right? Which we have some say in it, that what I should consume, what I should not, to help
Yes.
all these systems. Is it?
Food is one of the things we consume, but we consume
Yeah.
way more than food. We
We,
consume content.
yeah.
We
Yeah.
consume relationships, right? We consume, we are constantly consuming from our five senses. The consumption is not just food.
Yeah. Yeah.
Consumption is everything, and all of that affects. Food is the grossest of consumption, but everything affects. And we'll see that a little bit, because the nervous system interfaces all our consumption, including the food. And all of that affects us. And we'll see how. So there are some nuances in the nervous system is what I want to get to today. So we understand that. But this is important to know. All of this is also working,
Yes.
like you said, right? This is the mechanics, but nervous system is the controller, right? These are like the keyboard, the screen, the mouse, etc., right? But the processor, which is sending commands on what should be seen on the screen, right? How to interpret what is typed on the keyboard. What does it mean? All that is done by the processor, right? The nervous system. So we'll see that a little. But yeah, this is all our interfaces. Very important ones though.
So one of the things that I was just thinking is, it's not just when a child is in the womb, when the baby is in the womb, the baby is not just taking from the mother, right? So the giving back of the DNA is a revelation for me, because, I didn't know this as a fact. Never did I read it anywhere. So there's also this give and take. It's not just being in a very helpless state and not doing anything. So
that happens, yeah.
Yeah.
And still there is a boundary. Because
yeah,
not everything can be exchanged freely.
exchanged.
There is both ways, right? So mother can't give everything. That will not be best for the child. In the same way, the back channel can't be fully free. Say selective, semi-permeable, flexible boundary. That's the essence of life in a lot of ways. For life to thrive, that's very essential. Yes.
I used to joke with my kids and wife that when they listen more to her, I said, you have a 9 months advantage. Now I know the science behind it. Right. That what all that advantage is.
Yes. Good. Okay. Shall we continue? Right. Good. Okay. So now we have the excretory system. I think probably the underrated, but one of the most important systems, because we really can't survive without it. Right. And this, again, it's important to know at some level, this starts from the cellular level. That's how important it is. Some of the others are less evolved, but the excretion happens at each cell level. Constantly, every cell is producing dead tissue or dead material, which has to be excreted out. So the semi-permeable membrane of the cell has a big role in letting out things, of letting out damaged chemicals, of things which have been used. Otherwise, the cell can't survive. It will be full. And if it is full, it will burst out if it doesn't excrete what it doesn't need. And same thing will happen with us. Right? So excretory system, very important component of it, of us, basically. Then the musculoskeletal system. So some places, this will be separated as muscular system and skeletal system. That's why the number keeps varying. But some it will be combined as the musculoskeletal system. In some, you may have the urinary system as separate, some in which it's not even showed as separate. It's put in the excretory system. So that's why the number keeps varying. Sometimes the terminology is different. But the musculoskeletal system is another amazing system. It's obviously the structure that it gives, but it's amazing because it's not, now it's more and more being discovered that it's not like a structure like say a building. Typically, what is a building as we know? We put a brick, another brick, like a Lego, right? It's fundamentally, we know things stack up like that, one above the other. But if we just take a skeleton and we stack it up, do you think it will stand like a building? No, right? It will fall down. It doesn't stand because it's not built only on this. And that's why it's used musculoskeletal, but it should also have what is now known as the system of fascia in it, which is ignored in the old science. In the modern last 5-10 years, they have started adding that. But muscles is what keeps the structure together, right? And in muscles operate, one of the other very interesting things about the muscle is that there is always a agonist and an antagonist. They operate in pairs. Okay, so what does that mean? That it's like, if you can imagine like a pulley. If I pull this will go up, right? So if this is a muscle, it will relax. If there is tension here, the complementary muscle will relax. Now, if I pull this will relax. So there is like a counterbalance in our muscle. So across a bone, there will be that counterbalance of muscle. So if I just imagine this arm movement, like this bone from say the elbow, the shoulder, there is a muscle in front and muscle in back. Now, when you will tighten this muscle, you will find the back muscle is loose automatically. And when you now tighten the back muscle by stretching it this way, this will become. So they are counterbalancing each other. And this counterbalance of multiple muscles is engineered so beautifully. That's why we are able to stand upright. Otherwise, this is not supposed to stand upright. Right? Only a live man you can know, right? You know, will stand upright because there is signals constantly going through our nervous system telling this muscle to be tense, this muscle to be relaxed. So just posture, just standing upright is a huge piece of activity. It happens effortlessly now for us, right? But it's not really effortless. So many muscles, this counterbalance, balance, this has to come in. And this is now what is known as tensegrity, tension integrity. So tension and compression both play a role. Compression is the Lego blocks where there is just pressure and there's an action reaction force. Tension is what exists in strings, right? When I pull a string, there is tension in the string. So basically thin things like our muscles, etc. have tension in it and our bones have compression. So a combination of tension and compression is what keeps us upright. And I don't know if people have tried this. I'm sure people have lifted babies up, right? Babies or children. Have you found that the same child sometimes feels heavier and sometimes lighter? Has this happened to anybody? Like slightly older, I would say, not ekdam young children, but like post, they can start standing up, 2-3-year-old, etc. Like say a child doesn't want to be picked up. Then if they are slightly heavier, they feel heavier. It takes more effort to pick them up. Or if they are ready to be picked up, then it's very easy to pick them up. Even a heavy.
Yeah.
Yes, Megha is nodding.
Yes.
Yes. You want to say more? Like give an example specific.
Yeah, like for example, when my son is crying and he doesn't want to come along, like, so, and it just is very difficult to hold him and get him. But in normal life, if he's not well and you have to hold him, we can take him.
How old is he now?
He's 6.
6. Okay. So not less weight, right? About easily good weight.
19 kg weight.
Oh, yeah. See? And that's what, if you see dances, right? Now we are seeing this dance on TV where people are so easily lifts and all are happening, right? So that happens because the person who is getting lifted, that's why they talk of trust there. That trust is so important that when that person trusts, they contribute to the lift. So their muscles will be in a way that they are lifting themselves partly. So only 5-10% is really the energy that the lifter has to apply, like in the child case. When they start supporting, so that tension, that body, the muscle will start becoming this way, that, okay, I am in this more easily to be lifted. And they start lifting themselves, then you just need a nudge for it to happen. That is tensegrity. That's the kind of thing that happens with this beautiful balance between tension and compression. Yeah, Sanjeev.
So Sandeep, then people who do acrobats or gymnastics, so they kind of take this awareness or control of their skeleton musculoskeletal system to a very high level or something. Is it trust and
Yes, totally.
ability?
So to move their muscles in that way, right? To be able to push their weight up so that the next person feels it's very light.
Yeah.
But I imagine, right? Though typically, exactly, those two dancers, you see, they are similar weighted, right? 80,
Yeah.
60, 60, right? To lift that 60%, 60 kg, you give them a 60 kg bag, it will not be easy. It will be very different than lifting a 60 kg person.
Lifting. Yeah.
That's one way of seeing it also. That's another. Yes.
Very fascinating. Trust, which is more like a thought, feeling, and then there is like muscle, which is grosser and wow.
That's where, like what Sanjeev was saying, right? Our mind, because it's giving those signals to our nervous system. Okay, relax, you can be lifted. So, and it will start doing that with practice. That's what practice does. It will create that command to allow those muscles to be in a way that they can be very easily lifted, and they contribute to that lifting. But that will happen if there is trust. Otherwise, they won't. They will resist. No, they'll become heavier. Like even child. There's a child is a very simple example for them to do that. Good. So this is the musculoskeletal system, but there is again, they have missed out a complete system which is now being called as the fascia system, FASCI. People who are interested can read.
Fascia is not part of skin, or it's a different.
Yeah, it's now being called as a separate system altogether, because so fascia is essentially, which was, so one example that's given, it's interesting. Like now we are getting Amazon boxes, right? Usually we have a bigger box than the item, so they fill with things, in it.
Yeah.
So that's like what they say, the filler tissue in our body is fascia. So earlier it was just seen as filler and thrown away when they would do the dissection. But now they are realizing its importance. It's so important because it creates a structure. It creates a support again. That fascia creates a support. It is what really can move and flow also with your movement. So when we do, for example, a yoga asana and we hold and we move our hands slowly versus fast, the big difference is when you move it slowly, your fascia will move. When you move it fast, your fascia won't move. It will stay where it is. Again, if you move it slowly and you hold, your fascia will start getting set in that new position. When you don't, it will stay where it was.
Yes.
So first move it slowly, allowing it to flow, and then you hold for it to stay, and you will start feeling it heavier because your fascia has shifted and your nervous system hasn't yet learned how to manage the weight in this way. So it has to give a new kind of command to your muscles to just lift your weight of your hand only. Forget any additional weight on it. So it has to learn. So you keep your hand, kitni der rakhoge, see? 1 minute is okay, 2 minutes, 3 minutes. You'll start feeling that pain, because that things are shifting. The whole weight structure is shifting. Where you need to apply weight is shifting. Aisa. Yes, Sanjeev is saying he has felt benefits of slow movement. Yeah. What kind of benefits say more, Sanjeev?
So one thing I did realize is, like when I raise my arm, and it happened in one of your DIY class only, where we did like this and this. And I noticed that in slow movement, I can feel where my weakness is, like where in my whole body, that awareness started to come. Yes. Whereas earlier I would be able to lift like weight like this, and it was very different when I did in a very slow motion. That awareness increased, I think. Awareness increased
because different components of your body started getting engaged. Earlier, you had awareness of just what was being used, right? Because you were leaving it fast. That got trained. So, uska pura awareness hai, the part that you are using. As soon as you make the movement slow, different muscles are getting used.
Yeah.
Different components of your body is getting used. And we'll see
Yes.
now in the nervous system, every component of our body has a nerve coming from there to our brain. So because now a new component is being used, a new kind of signal is coming, which wasn't there only.
Yes. Yes.
So your awareness is higher because it's a new kind of awareness. It's a new component.
Yeah.
And then to manage that new component, you will need newer commands, newer muscles, different configuration of your muscle to be able to use them. So now newer science people call it differently and call it a different system, a fascia system, because they are saying that this is also like a network. So it's not isolated. Earlier, the belief was the fascia here and the fascia in my other arm are disconnected. So they thought it's separate fascia, right? But now they are finding that this is actually connected physically through what is known as the extracellular matrix. So there is a tissue, connective tissue, which connects the entire body as one body physically, not some mystical energy, prana, which we cannot see, but this is actual physical connection, cells, tissues, which connect, like bonds, physical bonds that are connected.
So is this some kind of a layer beneath the skin?
Yes. And
Okay.
inside also, not just skin, even inside, like our organs here, around the organs, not just the surface level, but everywhere. So around the heart, there will be this. So heart is encased in some tissue. Every cell is like that. Possibly, I have to understand this a little bit more. That you asked, maybe the cells inside also, they are in some sort of a matrix, which is connected to the outer matrix. So this is outside the cells, extracellular tissue.
Yeah, because everything which is there on the macro is also there in the micro, right? They're not like separate things. I don't know if I'm able to understand this. So the cell has to have some kind of a cover, and then the tissue has to have the organ and stuff like that.
Yes. So it's all connected. So each cell is technically connected to every other cell through this matrix, physically, not some mystical energy, not some right now soul, spirit, keeping those aside, just very gross, they are connected.
The concept of fascia was not there in biology, I think.
It's
Is this
like
a recent thing?
5-7 years, last 5-7 years.
Okay.
I'll share a playlist I had made, which I shared with the Science and I guys. I'll share it on this group.
Yeah.
Some idea you will start getting what this is. More and more work is happening. And they're finding, so things like why deep tissue massages work, if done right. Right? It's because it manipulates the fascial system. Body work, massage therapies, a lot of that. Yes, Pooja, you had unmuted some.
So if I have to understand slow exercises versus fast exercise, so they work on different parts of the body, or is it always that slow exercises are definitely better than exercise like, I don't know, dance or something else, which is more of fast exercises?
I would say they are different for different goals. They will serve a different purpose.
So there should be a mix of both.
It can be a mix, yeah. Usually, and is the usual answer.
This and that.
Till you get to a certain place, then both don't matter at some point to stay in that. But yeah, you need a lot of work to get. Okay, good. So now, Bapre, we have almost 20 minutes left. We are just reaching the nervous system. I've spoken way more than I thought. So
This is really good. Really, really good.
So now the nervous system. So nervous system is really, as we know, the messaging system. It's the controller behind all this. So we'll see how it controls and what it does, right? Functionally, high level, we know. So broadly, right, to start at the structure of the nervous system, we see it as two parts, what is known as the central nervous system and the peripheral nervous system. So this orange is central nervous system, which is largely the brain and the spinal cord. Okay, and peripheral nervous system is everything that originates from this brain stem and the spinal cord to the rest of the body. So like our face, our eyes, our hands, legs, it's gone to the deepest corner of our body. Every organ it reaches, to the tip of the toe, to the tip of the finger. There's high density actually at the tip of our fingers. Very high density of neurons here. Right? So this is the peripheral system. Okay. The important thing, just this thing I learned a little later, so I'm highlighting, maybe all of you already know, the spinal cord is different than the backbone. When we say in this, the backbone is the physical bones that we see. Now, that is like a hollow pipe. It creates a hollow. And spinal cord is the nerves that pass through that hollow. So that backbone is a structure inside which I have all the wiring. My nerves. That is known as the spinal cord. So you will see these terms. So just to be very clear, so the spine is the backbone. The spine is the physical bone. So the nature gave us such a solid spine to protect that spinal cord, because that nervous system, the spinal cord, is so important. Every signal from every corner of our body goes through that. So the way the structure is very hierarchical. From our finger, the sense will go to the spinal cord, from the spinal cord to the brain. Similarly, if my brain is giving a command, move this hand, it will go to the spinal cord, and from there it will go to the different muscles. So spinal cord is a very important, like it's a meter box in our home. Oh, वही trip हो गया तो सब गया. Right? उधर से जो trip होगा उधर lost all connection basically. It is the intermediary, very important intermediary. But our facial muscles go directly from the brain, not through the spinal cord. Okay, brain and spinal cord, very important. And it's very beautifully designed again, very logical. In the spinal cord, all the upper spine, which I know as the cervical, right, 8 bone structure, that maps to our hands and shoulder, the upper part of our body. The lower part, lumbar, is all our feet. And the thoracic in middle is all our organs here. So very logical, very optimally designed, again, evolutionary, very beautifully designed, very logical, very systematic. It goes. That's why if an injury is here, it will only affect the lower part, doesn't affect the upper part. And there is redundancy also. So some nerves of the lower part will go to till the mid part. So there is some redundancy also built, very nicely designed again. It's not fully dependent on that. Some redundancy. So, but if there are 1,000 muscle cells, maybe 10, 20 will remain, but some is there. It's not fully gone. So very redundancy is one of the beautiful parts of this design as well. Okay, so now central nervous system is where the brain comes in, spinal cord. I've given an overview. Brain health will come to what that means a little, but now we'll go a little deeper in peripheral nervous system, because that's a very important part to understand. So peripheral nervous system has broadly 2 parts: the sense organs, the sensory side, which is coming through these 6 sources: our eyes, our ears, sound, our skin, which is across the body totally, our nose, our tongue, and our internal system. For 5 we know, right? Largely internal means, so if you close your eyes, you know where your hand is, right? Wherever it is, you will know roughly where your hand is. You know its position, right? Even if you put it this way. What is telling you where the hand is if your eyes are closed? How do you know where your hand is? Right? Because there is an internal sensor which maps every bone in your body. It tells you every bone where it is positioned. So you know where you are in space. You don't need your eyes for doing that. And sometimes that's why when we do yogasana, we say close your eyes and do it. So that this system, this is known as interoception, internal perception, becomes stronger and stronger. Right? And that's why it's not the ears. We see in martial arts, eyes are closed, they can still detect. It's not just the ears, it's actually your awareness of space, which is there. which is a completely different system that is exists. Similarly, even if your eyes are closed, right? You have your empty hand, or you're holding a phone, or you're holding a bottle of 1 kg, or you're holding a 5 kg atta bag, you will know. Correct? Even with eyes closed, you know, roughly, yaar, ye 5 kg ka hai. How do you know that again? Because again, there is a sensor in every muscle of your body, which is telling it kitna force lag raha hai us muscle pe, how much is the weight, how much is the tension in that muscle. That is internal. So these are two very important senses which typically we are not aware of, right? Because we have gotten so dependent on our ears and eyes externally. But this is an internal section, and that's why do your practices with eyes closed. You will develop this further and further. And it will come, it's very important, particularly when it comes to reflexes. Right? Because this is what it has to control. Right? The reflex is when, say, suppose you are tumbling. Right? Something came and you tumbled, you're falling down. Then your reflexes have to kick in. There is no processing time. How much hand to extend to protect your head from hitting. Right? For that, what does it have to do? It needs to know, where is my head right now? Where is this bone? Where is my hand? How much pressure should I apply? So all this internal processing is going on. Right? So it has to become stronger and stronger. So that's the internal sense, very important. The other is the muscle part, the external, the command that is going out, which is going to our muscles. All the activity in our body happens through muscles. So in some ways, I actually think muscle is an extension of the nervous system. I think gross may we saw it as a separate cell, kind of cell, so we made it a muscular system. But it's actually an extension of the nervous system. Because all commands saying do this X is only and only executed by muscles, nothing else. Our bones get no command. Bones are, in some ways, you can say dead. Muscles are what make the bones mobile. So the command is going to the muscle only. Yeah. And there are 3 kinds of muscles in our body. The skeletal muscle, which we know, right? That's what we see. Smooth muscles are the muscles that move the organs. All the other organs besides the heart movement muscles are very different. They are called cardiac muscles. Different completely in structure. So that's why they have been identified as separate. But they also get command from the nervous system and move. Like if your stomach, your breathing, your diaphragm is moving. Diaphragm is a muscle to breathe. It's a smooth muscle. Your stomach is moving to digest the food. So how is the stomach moving? Because of a smooth muscle. Stomach cannot move. It is attached to muscles which are moving. Like we are compressing, squishing a balloon, right? That's how the stomach is moving. Right? So same with our intestines. There is some movement that is happening because there are muscles attached and they are sending the signal. Yes, clear till now that these 3 kinds. Now, there are 2 kinds of actions that muscles do. One is known as the somatic nervous system and the other is the autonomous nervous system. So what is the somatic nervous system? Is the voluntary or musculoskeletal system. So muscles which I can move voluntarily, like I'm moving my hand now. I say I give command. It's my voluntary movement to move the hand, right? This is voluntary movement. Some become habitually, but voluntary movement still. Like if I'm agreeing, I'll nod my head, or the Indian confused nod. Those are still voluntary movements. They happen by default, but they are voluntary movements still, right? Because they're moving a musculoskeletal system. The autonomous nervous system is the involuntary movement. Like our heart is beating, right? I am not moving, beating. I don't decide what rate it will beat. It will beat on its own. How much it has to beat. So Sushi is asking, sorry, he's driving an example of that being, sorry, I missed the timing. applying brakes.
So you were explaining, right, some of the reactions before your brain has time to
Yes.
process. So sometimes I have wondered, even when you're feeling sleepy, your leg automatically goes on the brake when you see someone. Was that an example of that? Is what I
Yes,
was
that
asking.
can be a reflex. Yeah, that's a reflex. If there is time, it will be well processed, thought through, but sometimes suddenly something comes, that's a reflex. That's a driver's reflex. Again, very important to know where the brake is, etc. All that. Yes. But they're still part of the somatic nervous system. So this develops this reflexes. Autonomous is all these in background, everything that's happening, right? Our food is getting digested. I'm not deciding I ate food, digested, waste came out, urine came out, all that sweating is happening, not decided. These are involuntary actions, again done through muscles. So what controls that is known as the autonomous nervous system. This is a very important distinction. And this is what is important. We'll get into the autonomous nervous system now. So that's the important part. What is happening, which you asked, right, Pooja, how to control the brain. What though we really want to do is this, manage our autonomous nervous system first, because that really drives our health. Now, what is the autonomous nervous system? So this again actually has two branches. Very interestingly, Sushri already has put the word braking in the system now. It's in our consciousness, and this is what this is. So the two branches are sympathetic and parasympathetic. So what are they? Actually, the best example is parasympathetic is the brake, sympathetic is the accelerator. I was going to say that. So anyway, Sushri has put it. What does that mean? So when we have an experience through our senses, right? Before it reaches our brain, there is some processing that happens in our brainstem, which is in our, sometimes people call it as the reptilian brain or the mammalian brain, the less evolved brain. Our full consciousness happens in our neocortex, which is very exclusive to humans, right? We can think of abstract things, we can logic, rationalize everything. But we have our instinct system, which is the same as in any mammal or any reptile. And that works in the same way because it's for our survival. Now, suddenly I'm going and a threat comes up, right? Best example, let's say when we evolved here in a jungle, we see a tiger or we see a snake. What I am supposed to do? I'll see a threat. I'll say, can I fight it? Right? Do I have a stick, a weapon? Can I? Chalo, leopard hai, chota hai, tiger, bahut bada, I can't do it. Leopard, I can fight it. If it's a bigger animal, beast, I can't do. I'll run, flight it. So either I'll fight or flight. And what does that require? That situation requires my sympathetic nervous system to get fully activated. And once that happens, it's like a program. ये 10 command एक साथ जाएंगे through different nerves. These are all nerves connected on our spinal cord, as you can see from here. It will dilate our pupils, our sense organs. I'll see more clearly. I have to get full vision. I have to hear very acutely. So I'll sharpen my hearing. I'll forget about salivation because that's why my airways will get relaxed so I can breathe. My heartbeat will start pumping because I need blood everywhere. Why? Because I have to run. I have to use my musculoskeletal system or I have to fight. Either way, my stomach will say, stop digestion now. So digestion is not priority. Digest hota rahega. Pehle jaan bachao. Bhago. Ya lado. Right? It will release more sugar in the bloodstream because I need more glucose. Jitna store hai liver mein nikalo, insulin secretion will come down so that it will say bhago, sugar badao, so that sugar reaches as the heart pumps more. Right? And same, it will stop urination, not important, right? Right? So it will start all these functions which are important to fight or flight. Put us in this acceleration mode. Full charge. Chalo. Accelerate. That's why sympathetic nervous system will get activated. These are hardwired now. This doesn't go to our conscious process right now. Then this is sympathetic. What is parasympathetic? Of course, almost the counter. Threat has gone. You tell your body, acha, threat has gone. Now what the body can do? Alright, okay, now let's reduce the heart rate. Let's start processing the sugar. I can relax. Digestion can happen. If I've got an injury, my immune system can start acting. Right? So this is known as rest and digest. Sometimes rest and repair. And sympathetic is known as fight or flight. So it increases heart rate, blood pressure, blood sugar, pupils, this digestive process and immune response. Very important. So immunity is also driven by this. So remember, our fundamental immunity is driven when we are relaxed. We can fight the microorganisms when we are free from the threat of the macro. Because first priority is macro threat, because macro threat is immediate. If I don't escape that, there is no point, right? There is no point of the micro threat. Micro threat, I can process it, I can take time, but not too long. Not too long also, right? If this stays on for too long and infection proceeds, I'll die as well. And very interestingly, this they have found that sympathetic is more controlled by the right hemisphere in the brain, if at all, and this in the left hemisphere. But this is the essence of how our system is responding. Now, what is happening? See, this system works on perception of threat. Huh? So it is not based on the stimulus, actual stimulus. It's what I have started interpreting as fear, as a threat. Now, in a traditional environment, that was largely these kinds of things, a predator or something which will really harm. But what has happened now with our, again, cortical brain, as we grow up from our childhood, our brain is mostly blank. There is no connection. But with our life experiences, we start saying, oh, this is threat. That is threat, psychologically. So we start mapping our environment to threat. Now somebody will say, and this happened with me, my parents, my dad, where I grew up in Calcutta, I was very young, less than 5. In our street, there were lots of street dogs. Bharke. And of course, a dog is suppose 2-3 feet. As a child, I am even smaller than that, right? So I was told never go out alone in the night. There are street dogs. And that was good advice because I was under threat. So I never got a chance to go. And that fear of dogs stayed till 2 years ago, till I became 42, because it got hardwired in me that dogs are to be afraid of. Even when I outgrew them, I could have managed them. And now my status in life till 42 was, I wouldn't go into a home of my friend with a poodle. A chotu sa dog, no, my dog hai. My entire system, sometimes I would go, I didn't know that dog would suddenly come. I have jumped on sofas of people's home. It was that bad. I'm not joking, I've done that. Because that's how it was wired. It has nothing to do with the reality. Because till the time your conscious mind is coming, it's already very late. This has started. Because survival is first. There is nothing. Yeah, this will kick in. This is beautiful. Thank God it is designed like this, right? That's how we can survive. But what is now danger has become very different. And that is built through our experiences. It keeps growing on in life. Later on, first job experience I have seen with my clients. Very bad experience, very bad boss. Shouting boss. But boss means that only now. So next job, even the boss has changed, but ek fear rehta hai. Boss ka. Very hard to overcome after that, till you really process it through your nervous system. Because it gets hardwired. And till the time you don't, every work environment, you feel like you are in threat. You are under threat, constant attack. So some people really can't perform. Good performers will start becoming very poor performers if they get into this zone. Right? They become dysfunctional almost. That can happen with other relationships also. It's all experience based. It's all experience based. What is threat? Very different. It just gets programmed and our system says this way. And if I, based on this, do you wonder now why hypertension and diabetes has gone up so much? Hypertension is what? Constant high blood pressure.
Yes.
Hoga hi na?
Diabetes
is what? Constant high sugar level. Now, by the time you're, why it's dependent on age, 35, 40. Oh, why? Because your threat perception is staying just constant, the body is staying. So it's staying that way. So it's almost always in sympathetic. So the way nature designed it to work was that it has to move like this, right? There will be moments of stress in life. You will do activity. Sympathetic has to get activated. खेत में काम कर रहे हो तो भी sympathetic चाहिए. Muscles use कर रहे हो, using energy, it gets activated. But then ठीक है, you come back parasympathetic. So it's supposed to be a smooth cycle like this. You keep moving. What happens? You move. Now there is threat. You kill. You say relax. No, no, threat comes again. Oh, no, no. So you get stuck here in this sympathetic zone. So this is not coming only. And that is what then diseases are about. Sometimes the worst extreme cases also happens the other way. To now your psychological responses forget. So you stay in parasympathetic and you get stuck. And you are not able to come out of it. Lethargy. Right? You get stuck in that. Some overactive response of parasympathetic. You can't come out of it. So stuckness in either is not desired. What is desired is this smooth flow. This smooth flow. So I'll take a pause here. See, this is the essence of what I wanted to share about the nervous system. That we have these two branches, both useful for us. The important thing is not this or that again. It is this and that. It's when. It should be in our hand. We shouldn't be stuck. And whenever we are seeing stuck or we feel stuck, means something of this is operating. And we need to get out of it. It may show up as a disease, as a pathology. So, or it may show up not this way, but another way. Asthma is same. Again, it's getting stuck in a parasympathetic. It's ulta. Asthma is parasympathetic because respiratory heartways are blocked. That's over parasympathetic. Relax in a that will happen if our sympathetic gets activated. And so what we are trying to do in all of these, even in therapy, that what you see in our Sanjeevani Jagruti body practices, slow movements, they are trying to bring this rhythm back. Fast movement will only do sympathetic again. Slow will force you to do this again. That's another reason to do slow. So we have done Sanjeevani Jagruti body, you know, there is QRT at the end, relaxation, right? DRT, Yog Nidra. All of those relaxation techniques are what? Parasympathetic. Whole day we are in sympathetic. Some activity we are doing. Right? Force your, because we are not used to now parasympathetic. So our body doesn't go by default. So you have to give it that QRT, DRT, IRT, Anapana, meditation. Whatever you are doing is to bring back, chalo, thoda parasympathetic ke liye time do. So this comes back. Even if it's stuck, it comes. Yeah.
So one question, Sandeep. So when we feel very stressed, or like you feel very stressed or sometimes depressed or panic attack or things like those, so all those are related to these
Yes. Panic attack is what?
nervous
High anxiety.
getting stuck, yeah.
So your breathing, your heart is beating faster than it should. Because it's feeling afraid. Panic, कुछ तो threat perception है, वो है नहीं, और वो trigger हो गया है. तो उस समय बस हाँ चलो बैठो, समता, as we say, equanimity, अच्छा, this is happening. Just sit comfortably. So one of the biggest things that helps at that time is your feet being comfortably on the ground. Why? Why that is important? The nervous system, the sense that goes from your feet, the nerves that are on your feet, right? That signal, when it goes to your brainstem, it tells the brainstem, it is safe. So it will reduce this sympathetic and it will start the parasympathetic. So this is default programming. This is the program that exists, that when my feet are like this, so there we use our cognitive mind. We overpower this system, which we have the ability to. Saying, but not just cognitively, not saying I am safe will help. It will help so much. But if you engage your nervous system, say, and you relax your back. Again, this position of the back being relaxed, being supported, that signal from our sensory nerves, right? That is going. It's telling our mammalian brain, our reptilian brain, it is safe. In a language which we don't know. It's in our, it's in that code, it's in that programming language, right? It's that signal. It is safe. It's a hardwired signal in our body. The other signal similar hardwired is seeing a pleasant face. So if somebody who's in front, if you are in front of somebody who's having a panic attack, you smile. You know this is just his sympathetic system overacting. You start getting anxious, they'll get more anxious. You say, okay, sit, it's okay. There's nothing to worry about. It's safe. I am there. You sit. See if you can feel your feet on the ground. Take their attention there. Feel the support of the chair. If that is not there, you keep your hand on the back. Give them support on the back. Let them sense that. Then they will start, and looking at you. So another part which hasn't come here is actually seeing. Our eyes, when they see a good comforting face, that helps. That sends another signal, it's safe. That's part of our social conditioning. It will feel safe. But if it sees another person, that's also part of our social conditioning. Panic will increase that. So imagine a tribe in a jungle, right? If one person says there is threat, another says, threat. One person says there is threat, the other says, no, it is false alarm. So that's again part of our evolution. Social conditioning.
Himanshu used to get these panic attacks, but whenever I used to tell him sit, so he said, I can't sit right now. I have to walk for a while. Yes. And then after half an hour,
that's okay. Yes. So you walk with him, be pleasant, walk. Chalo. Because now there is that flight energy. There is energy in the feet. That energy has to be spent. That has to be spent by walking only. Otherwise, it will stay. So yeah, walking is okay. Perfectly okay. But with mentally being relaxed, it's safe. Chalo, karte hai na. Walk. And that's why sometimes closed spaces where panic attack becomes worse because you can't walk, you feel trapped, it becomes worse. But sometimes when you cannot walk, then say, just the ground. That will give you safety also. Those two. And earthing, it does that. Earthing will again regulate your nervous system, particularly the parasympathetic. So that's a preventive thing that you can keep. And one last thing, we are also close to time. When the trick in this, if we are stuck, right? So we went, say, parasympathetic, maybe we are stuck, or even in sympathetic or in parasympathetic, wherever we are stuck. To get out of stuckness, you need some stimulation because it's like a well. So to come out, you need some stimulation. It won't happen just like that. So you do a little stimulation and then relaxation. So what you want is this rhythm: stimulation, relaxation, stimulation, relaxation. You don't want just relaxation also. So some stimulation is needed. Stimulation, relaxation, stimulation. So that's why we do movements. We do slow movements because movement means some stimulation is there. But you don't want excess stimulation. So you do it slowly. And that will give time to so many things. It will bring in, it'll engage your fascia. It will give time to your nervous system to come out of that stuckness. Fast movement, you are stuck only. वो तो आदत है ना, उधर ही, parasympathetic. You did fast, it was there. When you do slow, it will come out and then you're doing slow. So it will get time. It's like that ball coming down the slope. And they'll take it, then you'll get time to come down. Otherwise, it'll go up, come down. Aisa hoga. It won't go this way. You want it to go this way. So stimulate and relax. But relaxation is very important. Very important. So undervalued or underdone. We think, हाँ हमने काम किया, sweat किया, that is good. Relaxation, very important. You're hearing stories, right? Marathon runners getting heart attack.
Yeah.
Not enough relaxation. That's so both and fast and slow, stimulation and relaxation, both. So whoever had seen the earthing video, hopefully it was still useful. Yes, Megha? Right, you're in mute, Jay.
I said I'll see the earthing video. I
Achha.
haven't seen it.
Yeah.
Yeah.
Amazing session, Sandeep. Thank you so much.
Good. Yeah. If
Yeah,
there are
it was-
questions, please feel free. I hope it, yes, because it is still a lot. The recording will be up. Earthing session just puts this nervous system in context of earthing.
Okay.
Saying is just to explain how earthing works, on what it works. Because it works on our nervous system and all of that. This is the essence. Nervous system controls everything. Like you saw all other systems, what Sanjeev was saying, it's through our nervous system. So very important. And now
Actually, this
Jaya,
is
I
the whole
think
Huh? Sorry.
I'm saying Jaya, the body, Sanjeevani Jagruti
Yeah,
body,
yeah.
hopefully got some more masala now.
Yeah,
The
yeah,
background
yes.
behind it, right? The
Sahi
background.
mein.
behind it.
So much of more masala.
Yeah.
I mean, I'm thinking
Yeah.
like, in school I did study biology, but वो बहुत पुरानी बात हो चुकी थी. So there are so many new things come up, and this is really beautiful.
So in biology, know this, particularly medical, this I have seen now. What we learn is at least 30 years behind what is
Yes.
known. At least 30, if not more.
Sure, sure.
The image of the cell that is taught in schools is 100 years old and has not been updated. Most textbooks, it has not been updated. And it's far different now. Just the picture.
Yeah.
And that will tell you 100 things. Like we say, an image
Sure.
can say 1,000 words. It's more than 1,000. Good.
Please get more sessions on this, all the parts of biology. I think that would be very fascinating.
Agle month mein so that you can do, you can start putting in topics. I was going to say, if this
Yes,
is
yes.
working, put in topics that you would like to. So I'll do my research and try and put together. Will be learning for me also every time. Otherwise, I'll right now to pull in whatever material I have from here and rehash
Yeah,
some
yeah.
science and I stuff only. I'll keep. Nice. Okay. Thank you. We'll close with survey.
Yeah, yeah.
Yeah.
Yes.
We'll do
Thank
that
you
all
so
together
much.
again. Just sit comfortably. Try and see if your feet are okay on the ground. If you're on a chair, your back is supported. Om Sarve Bhavantu Sukhinah Sarve Santu Niramaya Sarve Bhadrani Pashyantu Ma Kaschit Dukha Bhaveet. Om Shanti Shanti Shanti. Thank you. I wanted to ask a permission. It's at the end, so it's good. These videos, at least this one, since we're not shared any specific site, is it okay if we make it a public video? Like all our session videos are private videos, right? So if this is okay, yes,
I think
everyone.
that's fine.
Thumbs up.
Yeah, yeah.
Yeah, yeah.
Yes,
Yeah,
absolutely.
this is okay.
You have consent now, at least from people.
Yeah,
Yes,
yeah, yeah.
yes.
No, this class is very helpful, Sandeep. That today's class, it was amazing. Yeah.
Thank you.
I wish
let me know.
everybody who is starting to read biology attends this class, starts with this one.
Exactly.
That's why I want to put it out, at least see whoever wants to see. You guys also feel free to share with anybody.
Sure, sure.
Want to make it a public video so that it's.
So thank you, Sandeep. Thank you,
Thank you.
everyone else.
Thank
Thank you so
Name,
Thank you,
much.
everyone.
Thank you.
Sanjeev,
Bye.
Sushil. Bye.
Bye. Good night.